Already live streaming. Pairing live stream. It says it's working on it.
Professor, it's working. I just clicked on it on YouTube.
Oh, already live streaming. Oh, okay, there we go. Pairing live stream. It says. All right, good. So you got it working. Okay, good. It's working. Then I will just go back to not that page. Okay. Okay, so today's Thursday. We don't have as much to do on Thursday. So let's talk about stuff. That's most. Today is the end of 7.
The screen, you are not staring the screen.
What?
You are not staring the screen. We cannot see anything.
Okay. Let's share screen then. Let's do that. Am I sharing screen now?
Yes.
Okay, so homework 7, which is, wait, this is mod 8. Oh, I'm sorry, this is the wrong one. Just so you know, so there's 2 things on the homework that's due this week. Optimization, which we went over last time, and indefinite integrals, which I'll go over today. Okay. The group work analysis is due next Tuesday. Okay, that's the one where you find the maximums and inflection points. And then we're going to spend the rest of the class. I'm supposed to cover new material, but I'm not going to cover new material. I'm just going to review for the midterm next week. Okay? Do you have any questions about the midterm next week? It's on Friday or Saturday. It's an hour and 20 minutes long. It's around 20 questions. It's 200 points. It's 20% of your exam. Any questions about it?
How many is it like multiple choices and like short answers?
The only thing that's slightly different about this one from the test you just took, you know, the questions that were multiple choice, like what happened here?
Yeah.
So the midterm, I told you this before, the midterm questions are different. There's a whole bunch of things. It's a menu of stuff. There's like 6 or 7 things, and it'll say what happened here, and you have to pick all that applied. So if it was a product rule and a chain rule and a quotient rule, then you have to say all of them. So it's a little harder, but it's not impossible. I can give better partial credit for that. Because if you pick something, then it's not right, but you have, you know, I can give partial credit for those. The ones on this last test, I could give no partial credit for. Okay. Any question? Okay. All right. But that was a good question. All right, what's this? That's not that. Okay. So let's talk about the last time we talked about optimization. And you have a chance to do those homework problems. This time we're talking about indefinite integrals. So, by the way, for optimization, make sure you know this box problem because I love the box problem. Okay. Pretty much all you have to do is set it up and it'll look something like this. Volume equals x times one side minus 2x, the other side minus 2x, and then you just find the maximum and decimals. Love this problem. Look, there's a whole lot of discussions on this problem. I like this revenue problem also because it's super easy. All you have to do is plug that formula in and find the maximum. So that's easy enough. right. This river problem is a good one too. Where you have to minimize the perimeter. I've definitely seen that one on tests before. And for that, most people don't even draw a picture. They skip right to the perimeter is equal to 2x plus whatever the area is divided by x. And then you just click on the minimum. This one's never on anything. This curve one is sometimes on the exam, but not often. Because it's not that hard, it's just remembering the distance formula. And I'm not sure the distance formula is in your formula sheet, so that was what makes it a little hard. And this one is too easy. Okay, starting a new topic of importance. Okay. Let's start with our questions. Where are our questions? Lesson mod 7. Let's see who's here. Slade, are you here?
Yeah.
You have a better answer. So I'm asking the same question I asked you before, but I expect a good answer quick.
Okay.
Why are you here?
To learn about functions, the function of life.
No. That's pre-calculus. The functions are pre-calculus. And functions of life are only in novels. What calculus?
Study
What is-
change.
The study of change. And what are you studying?
Functions. Whoa.
No. What's your major?
Oh, business administration.
Does that have anything to do with change?
Yeah.
All right. Okay, so you want to update your answer to something more exciting than what you said?
The study, or no.
Why are you here? Why are you here? Give me something nice that has to do makes calculus feels. Pretend calculus is your girlfriend. You're trying to make calculus feel good. Calculus is all about change. Why are you dating change? Because you're a business major and what? Can you make the connection at all?
Because stuff in business is changing all the time.
Yes, calculus loves that. And so therefore you're studying this because you want to be able to talk about that change. Good. Acacia, what are the two rates of change?
Average and instantaneous rates of change.
Right, so those are two changes. So those are two changes you want to talk about. Talk about any change at all, you're going to talk about average and instantaneous. Okay, even if you're talking about the bank and how they give you money. If the bank gives you money, is that average rate of change or instantaneous rate of change? When they say 5% a year, is that average or instantaneous?
I don't know, average?
Yeah, it is. For instantaneous, they'd use a different formula.
Okay.
Okay. Good. Thank you, Acacia. Cody's never here. Why is his name even down here? Okay. Curve. What is the derivative of x to the nth power?
N times x to the n minus 1.
Okay, so that's a quick and dirty rule for derivatives. You're going to remember that because I'm going to ask it for you. Later on, I'm going to ask you the power rule again. That's the power rule for derivatives. All right. Rudra, what's the quotient rule say?
It's a denominator times derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared.
Okay. That's a messy rule, but it is a derivative rule. So remember that. What?
What was that again?
I just want you to remember because I'm going to call on you later on. Sebastian, what's the derivative of e to the x?
The derivative of e to the x equals e to the
E to the x. And what about the natural log of x?
and the derivative of ln x equals 1 over x.
Okay, ln is natural log. Look, Pam is not here. Pam, are you here? Going once? Going twice? Gone. Jonathan. What does the chain rule say?
It says the derivative of the outside, leave the inside alone, then multiply by the derivative of the inside.
Very good. Pavani is not here. And I need this question answered. Alicia, could you answer Pavani's question? Yes, what is the relationship between position, velocity, and acceleration? If I have the position, yes, go on.
And velocity the second derivative?
The other way, yeah.
Oh, the other way.
The velocity is the first derivative. And acceleration is the second derivative. Okay. So remember that.
Step on the floor.
Okay. Oh, Pam is here, so she can answer her question. Pam, what's the derivative of sine, cosine, and tangent?
I'm sorry. Other question.
The derivative of sine, cosine, and tangent.
Oh, cosine, negative sine, and secant squared.
Okay, fine. I don't know why I'm asking Acacia another question. Eric, what is 0 times infinity?
It is anything. Like 0, infinity, or any number, some kind of number.
Okay. Aiden is not here. He said he might be late. Selena,
Yes,
what is an inflection point?
is when concavity changes.
When the concavity changes. And Luke, what are critical numbers?
Are there x values where the derivative is 0 or undefined?
Right. Okay, very good. All right. All right. Moving on. Now we're talking about subjects. So in math, whenever we invent something, okay, we undo it. So, Sebastian, what undoes addition? Subtraction. Lalisha, what undoes multiplication? Division. Very good. Rudra, what undoes the sine function? Inverse sine. What undoes the sine function? What undoes the square root function? What will undo the square root function? Squaring it. There we go. Squaring undoes the square. So everything we've done in math, whenever there's something we do, we can undo it. Okay? So far, except, there's one thing I don't think we can undo is limits. We can't really undo limits, but we can undo derivatives. And we undo a derivative, it's called an antiderivative. So here's an example. I take a derivative of x cubed plus a constant. What's the derivative of x cubed plus a constant? The power rule. Who had the power rule? Barb? Do you have the power rule? Well, what's the derivative? What's the power rule say? Yeah, bring,
and times x to the n minus one.
right, that's this one. Is that correct then? 3 and the derivative of a constant is 0. So look what happens. We're going to undo that. When we undo 3x squared, it's going to give us x cubed. Now the undoing is with this symbol right here is called the integral symbol. So it's the integral of 3x squared, and then that dx is the differential dx. Okay, so it's the integral of 3x squared dx equals x cubed plus a constant. Okay. You can always check it. You can take the derivative of x cubed and make sure it's 3x squared. All right. There's two types of integrals. This one is called the indefinite integral. Okay. And it looks like this. It's an integral. It has a function inside and a differential. And the way you say it is the integral of f of x dx. Are you with me on that? We can say it out loud. The integral of f of x dx. I have the slides for that. Equals. If you see it, notice this. Look at this. Look up at your screen and look at this right here. See that capital F? All right, you're going to miss this. You're going to miss it on the test because it's definitely on the test, probably on the next test. When you see a capital F of x, you do not say capital F of x. You do not say f of x. If you see a little f of x in an integral sign and you see a capital F of x, that's the antiderivative. Okay, so up here, the little f of x is the 3x squared. The capital F of x is this x cubed. Okay, little function, the little f is the function that's inside the integral, sometimes called the integrand. The antiderivative is what comes out of it. Okay, and it's a capital F, and we rarely use capital letters for functions. And in this class, you have to be very careful that capital. I assume that if you're talking about antiderivatives and you write a capital F, you're talking about an antiderivative. Okay. Everybody okay with that? Because that's totally on the test, and I see people miss it all the time, at least on a quiz. All right, the definite integral. The definite integral is an integral sign. It has a little a and a little b, and then it has a function and a dx, and it means something completely different. It doesn't mean antiderivative. It means the area under a curve between a and b. Okay, what's powerful about this is we're going to spend the rest of the semester knowing why there's a relationship between the two. Why do we use the same notation? If we're talking about finding the area, why can't we just use like a capital A? Why are we using the integral sign for both of them? Because it turns out there's a theorem we're going to study called the fundamental theorem of calculus. There was only one fundamental theorem of algebra. Now there's one fundamental theorem of calculus, and it basically is the relationship that connects these two integrals. Okay? And that area is defined somehow by the antiderivative, but we'll get to it later. Okay. So that's the notation. That's how it's said. Okay, so what's the derivative of e to the x, Sebastian? What's the derivative of e to the x?
It's e to the x.
Okay, so what's the antiderivative of e to the x? What's the integral of e to the x dx? We know the derivative is e to the x, so it's the same thing, right? If the derivative doesn't change it, then the antiderivative takes it back. What's the antiderivative? Same with you, Sebastian. What's the antiderivative of 1 over x? No. You're reciprocal. That's a reciprocal thing. No, what derivative gives you 1 over x? You said it. I asked you two functions.
Oh, it'd be natural log of x.
Natural log of x. So the antiderivative is, oh, Pamela. Pam.
Yes.
You were given the derivative. What derivative gave you cosine? Which derivative of what gives you cosine?
Sine.
Right, so the antiderivative of cosine is sine. What's the antiderivative of sine?
Cosine?
Except that gives you negative, so it would have to be the antiderivative of negative cosine gives you sine. A negative sine gives you cosine. So the antiderivative of sine is minus cosine. Okay, so the derivative of cosine was sine, the signs didn't change, but the antiderivative of sine gives you minus cosine. How about the antiderivative of secant squared?
Tangent?
Okay. I don't like my notes after this, so I'm gonna go here. That one. Okay. So let's talk about some properties. Some rules. Okay, so do you remember when you took the derivative of f plus g? Remember this little f? Remember this? One of the rules was an addition property. You could take the derivative of f and then add the derivative. Remember that? So if I'm doing the antiderivative of f plus g, by the way, you see on Desmos, I got the antiderivative. I got it very quickly, but ignore these two boxes because boxes are for the definite integral, but I can just write it this way. So if I have the antiderivative of f plus g dx, I'll put those in parentheses so that I don't mess them up. Sometimes I don't put them in parentheses, it's fine. Equals, I can do the same thing. If the derivative was each one, then I can do the antiderivative of each. So I can do the integral of f of x dx plus the integral of g of x. Okay, so you have to understand the property you had here with derivatives is also true with integrals. Okay, how about this one? Do you remember that if I took the derivative of a constant times a function, do you remember I could just take that constant out and just say a times the derivative of f of x? Remember, if it's a constant, it just sort of hangs around. It doesn't go away because it's involved in stretching, but it doesn't do anything, doesn't get involved with the other derivative stuff. So if you have the derivative of 3x squared, which would be the derivative of x squared times 3. Okay, so the integral is also that way. So you can take the integral. If you have a times f of x dx, you can write that as a times the integral of f of x dx. That a comes out. Okay? That's all. The only thing that ever comes out of an integral sign is a constant. No good comes from taking anything else out of our integral sign. You cannot. If you do, life will stink for you. Okay? All right, so back to my notes. Now that we know that, oh, there's one other rule I wanted to do. Where's my notes again? Here. Okay. Power rule. Good job. You got the power rule? Or Garv had the power rule. Garv had the power rule. And so what's the integral of x raised to the nth power dx? Okay, this is a power rule. Remember before, so power rule, let's go back up here with derivatives. The power rule dx of x to the n was equal to nx raised to the n minus 1. Fine. Okay, so what are we doing when we undo it? When we take an x to the nth power, what do we have to do? Instead of taking it down a power, we're going to do what? Integral is going to do what to the power? Reverse it by how? If I'm subtracting by 1, what would the inverse of subtracting by 1 be? Sorry. Adding 1. Okay, so x to the n plus 1. Okay. Can I ask you a question? If that's true, what happens if I take the derivative? So if you think that's true, and it isn't, the problem is if I take the derivative to check it out, if I take the derivative of this, what's the derivative of x to the n plus 1? What do I do when I take the derivative? Go ahead, tell me what the derivative is. You have power, will you have to get? What? Okay, I'm gonna do this. I'm gonna ask you to check this. What's that? No, I'm not taking, it's not x to the n, it's the derivative of x to the n plus 1. So what do? You're using that rule that you just did. You bring what down?
N times x.
You bring the n plus 1 down.
And x to the n minus 1. Plus.
Okay, so I take the derivative of this and I get this n plus 1. So I can't have that n plus 1 there. But what did I tell you about antiderivatives? I can put any constant I want in front. So I could put 1 over n plus 1 here. So that's a constant. So instead of putting it there, I can put it here. And instead of putting it here, I'm actually going to put it here. I'm going to put divided by n plus 1. That's the power rule for integrals. Okay? Are we good with that? About the derivatives. Okay, so now, here's a question for you while you're still thinking. I'm going to copy this whole thing that you just gave me. And I'm going to put x to the 3rd power. I'm going to let n be 3. So what's the antiderivative going to be? The 3 there. No, 3 there. So it's n. It's going to be what? X to the what?
X to the n.
No. N is 3 here. So x to the what power? I just plugged in 3 into all those n's. So just what's 3 plus 1? And that's over what?
4. So
that's a simple power rule. That's an example of a simple power rule. Okay? That's it. We're done. All right. Can we try another one? What's the antiderivative of x to the negative 5? What's that going to be?
negative 5.
Yep.
X to the power negative 5 plus 1 is 3.
4. Divided by what?
Divided by 4.
Negative. Okay. Are you get better at this?
Yeah.
Good. We'll try another one. Let's try one more power rule. Here's a hard one.
Yeah.
1/2. X to the 1/2 power. Would be what?
X 1 x. Add a decimal or just keep it in the fraction?
Can you do it in the fraction? 1 is 2/2. What's 2/2 plus 1/2? 2/2 plus 1/2 is 2 apples plus 1 apple. 3 apples.
5x.
No, 3/2. So what does the denominator become? Notice that the numerator and denominator are all the same. So what's that going to be?
So 5 by 2. 3 by 2.
3 over 2. You can also write, if you want, you could write it as this whole thing. You could get rid of that whole thing and put 3 down there and a 2 up here. Okay. All right, let's go back to my notes. I think we're ready. What's the antiderivative of x to the 1/2? Here we go. +1. This is the power rule for antiderivatives. It's just a little different. It adds a power and it shoves something in the denominator, and they always look the same. X to the 3/2 over 3/2. I don't care if you change it algebraically, just leave it the way it is. Here's x to the 5/2 plus 2x. Oh, here's one we didn't do. How do we do 2x to the first power? What's the antiderivative of 2x to the first power? Anyone at home? Oh my God, but I haven't heard from. Luke, are you there? Hello. Luke, I'm asking you a question. I'm hoping that you're there, but maybe you're not. All right. How about Jonathan? Jonathan, can you help me with this problem?
I can try.
Okay. It's nothing special. I want the integral of 2x dx. So what can I do with the 2?
Oh God.
Did I say you can do with constants? With derivatives of constants, they don't change anything. I can take them out like that.
Okay.
Okay, that's all I'm saying. Derivatives and integrals or antiderivatives, that constant doesn't matter. But let's take that number x. That is x to what power?
The second. So squared.
It's x to the first power. But when you do the power, it's x to the first power. There's nothing there. It's to the first power.
Oh, I was confused because the 2 before it that we moved.
Yes. But so if I'm using that power rule that I just did, I'm going to add a power. So it's going to be x raised to the what power?
If you're adding a power to 1, it'll be squared, right?
Yep. And then I have to divide it by 2 plus constant. Okay. Now I'm going to do something harder. I'm going to change this problem into something else. Okay, with me, Jonathan? I'm going to let you redeem yourself here. I'm going to get rid of the x. So that is x to the 0 power. Okay.
Can you just get rid of it if it's x to the 0 power?
X to the 0 is the same as 1. So now I want you to use the power rule again. Except if x to the 0 power, what are you going to do? You're going to, this power rule adds 1 to it, and what are you going to get? 2x to the what power?
It would be if you're adding 1 to the 3rd.
No, adding 1 to 0.
Oh, then it'd be 1, so you'll just take it away. Right?
Yep.
Or would you keep the 1 there?
And then you divide it by what?
Mm.
It has to
0.
be- No, divided by 0 would be bad. It has to be the exact same number that's up there.
Oh, okay, 1.
So 1, or it's gone. In other words, that antiderivative is just 2x. So I want you to see, if you have the antiderivative of a number like 2, it's going to be 2x. Okay? If it's the antiderivative of, so let me just ask you this, what's the antiderivative of 75 dx? It's going to be what?
75 And then that symbol, I forget what it is. Don't get mad.
X.
Oh, I thought we were doing the same as the above. Sorry, I'm really confused today
You
with
are.
this.
Oh, you were trying to do it. No, I don't, I was skipping right to the answer.
Okay, 75x then.
That's
Plus
it. So that's it. Let's see. So what would be the antiderivative of 81? Dx. It's just,
81x plus c.
that's it. All right, good. Thank you, Jonathan. Now, go back to my notes. So the antiderivative of okay. Right, so here's a problem that I'm not gonna do a lot of, because it's kind of nasty. Do I want to do this problem? It's in the homework. It's in the homework, but it's not that hard. Let me do this problem. The integral 1/2, 3/2. Get that out. Okay. Put it down here. Okay. I can't do this problem the way it's written, but I can do some algebra. I can take this, that x squared, and I can distribute it. Okay, so I'm gonna distribute it, and I'm gonna x squared, x to the 1/2. I take this x to the 1/2, and I'm gonna multiply it by this. I'm gonna multiply it by this. Okay, now what is x to the 1/2 times x to the 3/2? Anyone? What is 1/2 plus 3/2? 2. Okay, so this whole integral becomes x squared here. This is just x. Okay, now can we do this? Who wants to help me with this one from home? Slade, help me with this. How do I do it?
Okay. So you gotta. Oh, okay, that one. I was looking at the wrong one.
I've got this. I'm here.
Yeah.
Can we break it apart?
Yeah.
Okay, we'll break it apart this way. We'll take that away. Plus what?
It'd be plus 7x to the half. Right?
Say the integral of 7x to the half. Yeah.
The integral.
So there, I broke it apart. Now what?
And now you need to take the antiderivative of each
Okay,
interval.
what's the antiderivative of x squared?
X to the 3rd over 3.
Very good. Okay, and the next one?
I know we just did one with a fraction, but hold on. Let me look back.
Okay, well, the 7 can stay.
Yes.
I could have taken the 7 out, but let's just do that here. Okay, so now x raised to the what?
It'd be x raised to the 3/2
Divided by what?
divided by 3/2.
Yep.
Is this like the anti-power rule?
Yep, it's the anti-power. It's the power for integrals.
Hmm.
It was a power for derivatives. This is the power for integrals.
So it's like the reverse of the power rule for derivatives.
Yep, up here when I said the power rule for derivatives, These were the power, these were all the derivative rules. This one here is the power rule. For
Yeah.
derivative. This was, I just put an n+1 in there so that I could get the power rule for antiderivatives. That. These are the antiderivative rules.
Oh, okay. Thank you.
Just come from the derivative rules, that's all. Okay? All right. Okay, it's back to my notes. So you see how to do this problem? You distribute it and then you do antiderivatives and you get the, then you're done. Okay, here's a harder one. Let's talk to our expert. The integral of 5 sine 9. Okay. That's so not right. Nope, not so. Okay. So I'm just gonna, I should put parentheses on it, but I'm not going to. Okay. What do I do first? Anybody? Can I bust it apart? Yes. Let's just bust it apart. You don't have to do this. You'll, after a while, you'll be able to do these things in your head. So I just busted it apart. Now, can I do anything with the numbers? Can I take the 5 and do something with that? Can I just take those numbers outside and not worry about them? Yes, so put the 5 out front. Put the 9 out front. Just like with the derivatives. Okay, now I've done those 2 rules. Oh, Pam, what's the antiderivative of sine?
Cosine? Oh, negative cosine.
Oh, very good. She got her, so the antiderivative of sine is cosine. Okay, good. Okay, no dx. The integral's been done. What's the antiderivative? Aiden, what's the antiderivative of x to the 9th?
X to the 10th over 10.
Okay, what's missing?
Plus
Once
C.
I do the that's what's missing. Plus a constant. Once you do the antiderivatives, the c's have to show up. Okay. Any questions on this? What's the antiderivative of 84? Garp, what's the antiderivative of 84? Oh, it's 84 something. It's 84x to the 0. So what's the antiderivative of that? It's power rule. Add 1. 84x. That's just 84x. That's it. So it's 7 sine of x minus 84x plus constant. Good. Okay, here's a problem that we're not going to do, but I have a question. Who had the chain rule? Who answered the question, the derivative of the chain rule? Do you remember? Jonathan. Da, da, da.
Uh-oh, what's up?
Remember in the chain rule when you take the derivative? Tell me the derivative of the chain rule. Tell me the chain rule. What does it say?
It says the derivative of the outside, leave the inside alone, then multiply
Okay, stop right there. Leave inside alone.
Yeah.
Okay? All right. That's all I wanted to do. I don't need the rest of it.
Okay.
This problem that I'm not doing has a 9x on the inside of a function. This problem that I'm not doing is the antiderivative. This is undoing a chain rule. And we're going to spend a day or so trying to undo them. But this problem shouldn't be here, so I'm moving along. Okay. All right. That's all I have. So as far as the test goes, those are the sorts of questions we will see on the midterm. On the midterm, there will be a question that's antiderivative. And it's going to be one of those. Those are pretty easy. Maybe. You have to practice some of it. And one of the problems is confusing sines and cosines. Also confusing derivatives and antiderivatives. So lucky for you, this test is in order. So it's likely that the integral question will probably be one of the, actually it's not going to be the last. It's going to be in the test in various places. But probably the writing one, we have to do the power rule, that would be at the end. Or not near the end, not in the discussions. We have no antiderivatives in discussion, so there will be no antiderivatives at the end, but there will be antiderivatives in discussions. Okay. Let me talk about the discussions for a second while I'm here. So that's all I wanted to say. Any questions on antiderivatives? So you have on your homework, which one of these? On your homework, you have some optimization problems. Remember, I told you I like the perimeter one. That was number one for question. Oh, the paper. I love the paper one. That's number 2. Number 3 is the distance formula with the point. That's okay. The Norman window is totally not happening. It's just fun to look at. Won't be on your test. The hallway one is too easy. That's not going to be on the test. The company ratio, that one could be on the test. That's probably not on the test. Antiderivatives. So you see, this is question number 7 on the homework, and it just says, find the general antiderivative, and they give you a function like that. All right. And then we went over one like this as an antiderivative. And then here's another one. And that's it. Okay? Those are the homeworks. That's the last bit. Why did I ask you this? That too, because I don't need that. Okay. Let's talk about the discussion. So, did you guys do your discussion form the last time? Yes.
I don't think mine were finished.
Well, that's no good. Acacia, did you guys finish? You said you would finish last time.
Oh yeah, I think we finished ours.
Okay. Does everyone see this? You're saying there's a minimum at 1.8 hours. And by the way, Jonathan, oh, minus 1.8. So you see that would be there. Okay, yes. Question, there's the inflection point, and there's an inflection point. Good. What's your question? This is good. Who's got a question and why am I not? So here's Alicia, that's you. Oh, I see stuff. Oh, and I have a video.
According to the Quartic regression, there's a maximum at the year 2022. There are inflection points at years 1978 and 1991.
Connie, you sound really smart. You've done this before. So you read this one. And if I look at Pam, she's saying the derivative, okay, there's something wrong here, Pam. I see the second derivative is 0 at these 2 years, 1991. Uh-oh. If the second derivative is 0, those are inflection points. That's correct. I mean, it's correct if that's true. In which case Luke should say there's inflection points at Luke. Why are these years not matching her years? What's going on here? What's so special at 1978? Oh, because she wrote them here. She wrote minimum. And so if you take the derivative of 1978, it's equal to what? If it's a minimum, what's the derivative? Rudra, what's the derivative? What's the derivative at a minimum? The top of your head is flat like the earth. That's the top of the head. That's a maximum. What's the slope of the line that's flat as the earth? Give me a number. Thank you, Anisha. It's 0. So the derivative, Pam, you should be saying the derivative is equal to what? 0, not equal to the second derivative.
Oh yeah, sorry. I thought I wrote 0, so my
Right.
bad.
You're just missing a 0. That's all. So just plug that in and we're good. And this one looks good. Next post 3. Sebastian. That was yours, Alicia, right? So yours is good. Sebastian. According to the cubic regression, there's a minimum drug potency of 4%. And that negative, so it's one inflection point. So it's an inflection point, a maximum and a minimum. Looks like it. There's an inflection point, a maximum and a minimum. Okay, and you got the zeros in here. Good. Fine. So that's what Aiden said. All right. Is there anyone else in your group to present this? All they have to do is read that.
Eric.
They show up sometimes, don't they? Okay, last post, Sleed. Rudra. You're saying the derivative is 0, second derivative is positive. That would be a minimum. Inflection points are zeros. Okay, so what are you missing here? Inflection points. Rudra, what's missing? Yeah, there's something wrong here. If it's an inflection point, the second derivative should be equal to 0. That might be what it's equal to, but I need you to put 0 in there. I don't want you to put the number. The second derivative is the inflection point. Where did you think there was an inflection point? At 100? Or somewhere around 100? It looks like 80, actually. It should be at 80 that the second derivative is here, and then 171. Those are my two zeros. They're much smaller than these numbers. And then 53, 114, and 210 are also critical points. Okay, so fix that.
I get these right now, 0 again.
I'm not sure. Why do you have 75 when she had more than 75 written? 75 is not a max min or an inflection point. 53.01 is a max min or inflection point. You need all of these. 53, 114, 210. You have work to do. All right. Okay, that's it. All right. Let me talk about next week's posts because but
Did I didn't speak correct?
I don't know. I didn't play it. Am I going to? I can. If you wrote if you said what they wrote, I'm not sure you did. Yeah, you got to wait until they fix it because what you're writing is probably not right. Because I'll tell you why. Because I saw 3 max and mins and 2 inflection points. So you would have to mention all 5 of them. Did you mention all 5? Okay, so let's see. Discussion analysis. This is your slate. Okay, so Rudra only mentioned a minimum. and an inflection point. But I know, because I saw this, that there's two minimums, a maximum, and two inflection points. Okay, so Selena wrote the words. She wrote about the minimum and the inflection point. There's really more. There's another maximum and a couple more another inflection point, another minimum. So let's hear what you said.
Minimum at f prime of 75 equals 0 BFF per k. F double prime of 75 equals plus 0.001 BFF per k. And inflection point f double prime of 100 equals negative 0.04
You have
BFF per
more
k.
to say.
And according to the quadratic regression, there is a minimum amount of BFS at 75,000. There is an inflection point at 100,000.
But when I look at this, there's a minimum here. It doesn't look like 75, it's 53. So something's not right. That's a minimum of 53, and there's another one at 210. There's a maximum here that's at 114. But there's two inflection points. They're occurring at 80.36 and 171. So you guys should say you should say all of them somehow. Okay. All right. Don't just say one, like pieces of them, say them all. If you can. All right. Now let's talk about next week's discussion. Okay. I'm not breaking you up into groups today. Oh. But we're going to have a party. I want to hear what you're interested in. I want to hear everybody's interests. But I'm going to start with the fact that this is a loaded question. This isn't just a why you hear question that I asked. Slade, did I ask you why you were here?
Yeah.
Let's start with you because I've already picked on you, so I'll pick on you some more. Slade,
Yes.
what are you interested in that can be measured?
Wait, what was the question? Sorry.
What are you interested in that can be measured? What are you interested in? Let's start with what are you interested in? Anything. This
Like-
show and tell. We're going back to kindergarten and we're doing show and tell with our interests. I'll tell you some secret about me if you tell me some secret about you, and don't make it too secret.
Like anything in the world?
Anything you're interested in.
Baseball?
Do you have a specific team or player that you like?
I like the Mets.
Okay, so you must love Pete Rose then. He died recently.
Yeah.
He's not one. But the Mets, you like the Mets.
Yeah.
So the Mets is loaded with data points. So I would love it if you would track something about the Mets. Either how well they're doing or how badly they're doing over the years, or how many wins they get versus how much salary they pay. I mean, there's so many things you can get from the Mets if you like. That would be a very interesting topic for you to get. You need 9 data points.
Okay.
If you have any problem getting data, I believe that you are interested in baseball, and it may not be my favorite thing, but if it's your favorite thing, it works for me.
Okay.
Okay, thank you, Slade. Who's next? Who's going to show and tell an interest? Oh, I was supposed to do one of mine. It's one of my interests that I'm willing to share with you. I don't know. I have a lot of interests. I'm drawing a blank. Somebody else go. I'll think of something. Ballroom dancing. I took lots of years of ballroom dancing when I was at Rutgers. and I was pretty good at it. I'm not professional. I'm not Dancing with the Stars, but I'm fun. Women like to dance with me because I am fun. Okay? And by the way, when I go out dancing, actually, hustle dancing is my favorite dance. This is a difficult topic to talk about because it's hard to measure. I can measure, for example, how long I spend dancing on the dance floor each night over a period of time. Those are both measurable things. I cannot compare dances. I can't be like comparing a salsa to a Viennese waltz because they're not comparable in any way. There's just not, they're different dances. But I can't measure, I can't compare things. I can't, like, even if I said, oh, I like Viennese waltz and I like salsa, I can't talk about them. There's no numbers to go with them. And by the way, don't rank things. Don't use rankings like college rankings, because that doesn't work. And the other thing to stay away from is sanity or preference, like how much I like something. I love hustle dancing. That's my favorite. You also don't want to do like how cute people are. So I noticed this at the beginning of the night, there's like no cute people. And at the end of the night, there's lots of cute people. Why is that?
It's a function of alcohol.
Here you go, beer goggles. Very good. Good answer. All right, so you want us to away from things like what I just said. I'll think of another one later though. All right, who's next in the show and tell? I got Slade. Pam, do you have any interests that we can talk about?
Hockey?
You like hockey, really? Like
A little bit, yeah.
who's hockey? Which hockey?
Ice hockey?
Ice hockey? Do you have a team you like? A player?
No specific player, but I like the Devils, New Jersey Devils.
Okay. So what do you like about them? Jersey Devils, they win. Do you want to study their winning? Do you want to study how much they pay their players? Do you want to study anyway, you could certainly study it.
Okay.
Okay. But let's stay away from sports. Let's have some other ideas. Non-sports. Pavani, do you have any interests that are not sports?
Music.
Music's really hard. What do you like about music? Is it an instrument? Is it a band? Oh, who died? The One Direction guy died. I'm devastated. I can't name a single song with this song. But you could track success of a musician. You could track the success of, if you can find the data, you could find out how many records somebody sold each year, or you could. Stevie Nicks was on Saturday Night Live last weekend, was she not? Stevie Nicks, you know who she is? Fleetwood Mac means nothing to you? I'm sorry. When those old musicians come to play on Saturday Night Live, I feel badly because they never sound as good as they used to. But anyway, Pavani, can you tell me something in music that you might be interested in? Then I'm going to go to Luke.
Like what I would track.
Like what?
Like what is the question you're asking? Like what I would track?
What music do you like that you think you could get data from?
I don't know, maybe just like, I don't know, the streams, artist streams.
I don't know what that is.
Like how many like listens an artist gets.
Okay, so the lessons is fine, the artist is not fine. You can't compare people easily. But you can get glimpses of people. You can say, you know what's very interesting in music? Do you know the best music came from the 70s, from the 1970s? And do you know why they came from the 1970s? Anyone know why? Because the movies in the 1970s were awful. Has anyone ever watched any movies from the 1970s? No movie buffs here. Anyway, those
Gotta be.
movies. You what? You've seen movies from the 70s?
I'm at some point I've had to for sure.
I'm sure you did. Did you see Alien,
Star Wars,
Star Wars?
Taxi Driver.
Yeah, there's a lot of nasty ones. Anyway, there was a lot of money in music and there wasn't a lot of money in movies. Nowadays, there's a lot more money in movies than there is in music. So that's why the music isn't as good as the 70s. But the movies will suffer too. When they start having virtual reality movies and stuff like that, or AI generated movies where you actually you make your own endings or whatever, that'll be more fun than movies. You won't want to take your date out to a movie. You would rather go to an AI experience. Let's go to Paris. Let's do a virtual reality tour of Paris. Why would you go to a movie when you go to Paris? Okay. Anyway, Luke, what are you interested in? Anything? I'm gonna make everybody say something, so you might as well say it. Not music and not sports. And nothing boring. All right, think about it some more. Jonathan, what are you interested in that's not music or sports?
I really like cars.
Cars. You can do all types of numbers in cars. How much torque there is, how much, how expensive they are, all types of things. All right, Jonathan, I'm gonna let you go on that. Selena, not sports, not music, not cars, unless you're really interested in one of those, you better sell me on it.
Well, I am interested in soccer because I play it, so that's the only thing honestly I can say.
Okay, Selena, soccer it is. You could be interested in that. I know people who are really into one thing.
I am.
Yep. So is it a team or you could track your own? Oh, here's another thing. You could track your own success. You have your own data on how many goals you made from one week to the next. You could track that.
Oh, yeah, I can.
There you go. Just collect your own data. I like it. All right, who's next? Eric, what do you like?
I don't know, gaming stuff,
What?
playing video games.
Video games? All right, lots of. You can stay up all night and track how much sleep you've gotten versus how well what your scores do. You could do it. I'm saying there's a lot of numbers in video games. You just have to, you could do your own, or you could track the sales of video games. You like a particular video game that you like to study? No? All right, I'm moving on. Acacia,
I honestly don't know.
oh, come on. You like something. What do you like?
I like watching series, like TV shows.
There's so much
I
data.
spend a lot of time watching TV shows.
I watch a lot of TV too. There's got to be some data in there. You could track the number of commercials too.
Yeah,
That really bums me out.
commercials and ads, yeah.
Or you could track the amount, you know what I think is interesting? The amount of times they edit a frame. Like how many times they go back and forth. Like, have you ever watched a Marvel movie? Gives me a
I watch
headache.
all of them.
They give me such a headache. It's like, stop cutting the frame. Like they just like over here, over there, over here, over there. Like these people are fighting for 2 seconds and those people are fighting for 2 seconds. They bounce around. When I was young, I liked that stuff. Now that I'm old, I skip all of that. I don't go to the movies. I watch them and I just skip them to the end. And then if I see somebody's died, I'll say, oh, that person must have died and I don't care. Like, okay. They were probably killed some gruesome way. All right. So do something with movies, Acacia. That would be fun. Who else? Did I ask everybody? Alicia, what are you going to do? Reading? So you do you like particular art, not like read particular type of book?
Comics, web comics and stuff like that.
So you could track any of those published publications, how long it takes for those things to come out, unless they come out regularly. Do they come out regularly or do they come out when they come out?
Comics, depending on the like company and type, it might come out like once. A new issue might come out like once a month and maybe once a week, or they come out with like a full published book. It really depends.
Yeah, the problem I have with that is how often is very easy to, that's a good number. How big the book is also a good number, like how many pages or how many frames are in it. You could do that. But the type, you can't do that. Like you can't compare a comic, like a book, to a strip. Like, unless you're talking about the numbers of frames. Like how long does it take for them to produce this sort of frame versus that sort of frame? That you could study, but
I could also track sales, no?
oh, and sales. You can always, or yeah, sales of comics are very cool. Or how many, or how often they turn into movies that are awful. No, I don't know if the movies are awful or not. Okay, Rudra. I'm talking to you. Probably your interests. Come on, let's get this out of the way. I don't have all night. What are you interested in? I've heard that. Now you're gonna have to do it.
I'm interested in what we're hanging out. That's all.
Isn't that what he just said before?
Who?
Isn't Netflix and chill another verb for what he was just saying? I'm too old to know what that means, so I would literally mean just sitting around watching movies.
That is what it means.
They're laughing too hard for it to actually mean that, so. But I believe that it's that. But anyway, if you can make it less X-rated, you can certainly do something about it. Let me show you some of the ideas that some of the students had in the past. A lot of these were boring. Try to stay away from these. Look, I'm optimistic. So I don't want, my students have been so depressed lately. It's really sad. The last few years, some of them, I remember one time I had a whole class, half of the students did something about death. Death from pills, death from prescription pills, death from sexually transmitted diseases, death from specific sexually transmitted, death from a different sexually transmitted disease. It's all death. So let's stay away from death. You can track, here's variations, numbers of abortions, divorce rate, percent of condoms being used, the price of gold, HIV, accidents. Oh, lots of accidents, shark bites, people dying from shark bites. That was very popular in its day. Time sleeping, volatile organics dumped into the water, alcohol-related deaths, deaths from drugs, salary over time, salary. You can't compare salaries by profession. Oh, somebody did a really cool one year. They did the president's salary accounting for inflation. That was neat. Do you know who the most underpaid president was? Clinton. Because when he was paid, the inflation was high, so the money wasn't worth very much. So his salary actually dropped a lot. And you know who was the highest paid president? FDR, because he was the president during the Depression. And the money was worth a lot. So the president's salaries are fixed. They're like 100,000, 400,000, whatever it is. But when the economy is bad, that 100,000 is good money. But when the economy is good, 100,000 ain't nothing. So poor Clinton got ripped, because the next president after that was Reagan, and he gave himself a raise. I think it was Clinton to raise, no, Bush. Bush gave himself a raise. Okay, deaths by drugs, high school proficiency in mathematics. So don't stay away from boring things. Minimum wage is nice. Population. Anyway, you have to post. These are not a group topic. This is an individual topic. You're doing it on your own. So when it says proposal, you're going to propose the topic you're going to work on.
What are we doing with the topic exactly?
You're going to there's instead of a test 2 on integrals, you're going to do you're going to present your research. You're going to be the writer, the speaker, producer of every topic that we did so far for your data. And then you're going to make a video presentation of it, which I will play for the entire class to hear.
So like for each topic?
You get 5 minutes. If I don't like it, I'll send it back. I'm not paying more than 5 minutes for class. But if you found something interesting out about if you found, I'm going to be looking for limits. Well, when we get closer to the time, I'll tell you what it is. I'll be looking for limits. I'll be looking for average rate of change. I'll be looking for derivatives. I'll be looking for percent error. I'll be looking for integration. That's 5 of the 10 discussions that we have. Not all of the discussion. Oh, I will be looking for inflection points and max and min. So you have to talk about that. So you're going to talk about it. So like, let's say you're doing, I don't know, you didn't give it, Rudra didn't give me a topic. Okay, so let's say you might say movies were at a minimum in the 70s because the quality was like whatever it is. So there's a minimum, and there was an inflection point in the late 80s, and you could say, I predict that next year the limit as we approach next year is going to be such and such with such and such error, and the average number of moviegoers was such and so you could just make a presentation off of the data that you have. But the part that you're not going to present the math, you're just going to say what's very cool about you. I mean, you're going to fill out one of those worksheets, and fill the whole thing out from beginning to end.
We need to plot a graph like showing everything.
Yeah, you got to do everything.
Ups and downs and everything.
That's your worksheet. You're going to have a worksheet, and then you're going to present it. Be glad I'm not making you do a poster. I used to make my students do posters. A poster is like a movie poster. You just put the highlights on a poster. And you're just going to present as a video. You can just work right off the worksheet and tell me what you like, what you don't like. So you'll look at your worksheet and you're going to say, hey, you know what's cool about this? And you're going to talk about it. And you're going to.
Would you be able to do something like music notes? Like musical notes? And like their strength or their. Because there's like a measure, I think it's like dB or something, right?
People have tried musical notes, and while it's interesting, it doesn't. One of the things you have to watch out for is functions that are too perfect or too linear. Things that are linear don't have nothing going on. They don't have maximums, they don't have minimums, they don't have anything. Nope. And so I would stay away from something. If you want to ask me later on about any specific topic, I'm not committing anyone to doing anything. Okay, at this point, but even if you do your proposal, you change your mind before the end, that's fine, but I do not want you to change it to death. Yes.
Like when you say we need to speak, so like is it a video or like in front of the class?
You're not speaking in front of class anymore, because
Okay,
I'm
it's
done with
just
that.
a video.
You're going to go into Harmonize and you're going to record yourself.
Got it.
You give a presentation. If you share your screen, that would be nice. So you share your screen and you talk about it. So you work right from the worksheet. I honestly used to make it a much bigger deal. We used to have people do posters. My office used to be filled with posters. You know what a poster is? Like a movie poster. They were posters and they were big and they were awkward and they were. Sometimes they would glue things to them. Cars, racing cars. I remember someone did one year. I took pictures of them all, but then I threw them out when they kicked me out of my office a couple years ago. They would be doing the building. So
When is this due, Professor?
what?
When is the project due?
Towards the end. It's usually the week before. It can't be too close to the final. Thank you. It can't be too close to the final. Because it will be, can't be close to the final, because I need you to work on the final. This has to be done at least a week or two before. But we have to
So,
topics, and you'll notice that, yeah, let's go on. Okay, so keep talking.
so we're doing like what we normally do in the discussions, like,
Probably there'll be a discussion for you to post it.
so we're just putting in the data on Desmos as normal.
You're putting the data into a worksheet, and then you're gonna fill in all of everything in the worksheet, and then you're gonna present it. And, yeah, you're gonna do everything. Everything we've been doing each week, where you do one job and someone else doesn't know you're doing all the jobs.
Oh, okay.
It'll be good practice for the final, because those questions show up on the final, and people miss the questions. Knowing who the writer and the speaker was, there were people who confused them. And I don't want you to confuse them on the final, and so this is useful preparation for the final. That's why I brought the project back. Anyway, what were we talking about? Oh, what's due? So the proposal and midterm are due the week of the 29th, but then quiz 8 is not due until the following week. So you'll notice the quizzes are actually further back than the mods. Okay, because like mod 4 and quiz 4 were due at the same time, but now it's going to be pushed back. Okay, so the quizzes are a week later. It's just the way it works. Okay. Any questions on this? Oh, here it is. The project due is 12/7. Says it right there. I want to present them on the 12th. No, that's the final exam. Oh, I want to present them on the 10th. So that's what I'd like to see though. All right, any other questions on this? All right. So you got an idea of the topics that you want to do. All right. More review. Okay, so now I'm just going to remind you the next 15 minutes or so, then I'm going to let you out early. Linear approximations, you remember them? These are in this, so just so you know, they're in here because these were particularly hard questions for classes of mine in the past, but I've since decided to take them out. So this question is kind of moot. This question I've taken out. This question, no. Newton's method, this is not a question that I've taken out. You know how to do Newton's method. You know it finds zeros. I like Newton's method. It's in. Okay. It's a lot easier than back in the olden days. But these are all calculator stuff. It's a lot easier. How about concave up and concave down? Is this a good exam question or not? This one's particularly not good. But why is it not good? What would you do if it was asking for when something was concave up or concave down?
Derivatives.
Okay, so all right. So this is the function right here. So if they want to know when it's concave up, when is that? Concave up is when what happens? Concave up is when what happens?
Derivative is equal to or greater than 0.
The derivative?
Or
No,
second derivative.
Second derivative. If you want concave up, you want second derivative is greater than 0. If I turn that on, that's all of that. Does it look like it's concave up there? It does. But somewhere in between it's concave down. Can you tell me where it's concave down? Ooh. I don't know. That looks like 0. Looks like 0 on this side. On this side, it looks like 0.25 something. Okay. How do I get that number? I can keep zooming in and get that number. It's 0.28 something. 0.285, 0.285, 0.2855. Okay, I could do that. Or I could just set this equals to 0. Well, you know what I could do? Just take it out. I could just take it out. Just look for the 0 right there, 0.28571. Okay. All right. Well, what about the other one?
That's concave up. What is it?
This function is concave up when that is greater than 0, which I got this number by doing this. So that's the number on one side. What's the other side? In other words, I have an interval notation. I have from that number to infinity. That's one interval. And the other interval is what? Minus infinity? To some number. I just don't know what it is. What's the number? So that's this number. But there's another number. Look, when I ask for when this is greater than 0, you see, I get this where this dashed line is. But you see there's not another dashed line. Do you see that? Do you remember what did that when you didn't have a dashed line? Dashed line is because it's strictly greater than 0. If you say greater than or equal to 0, you get a solid line. Okay, but that isn't it. That is neither of those. That line right there is, I don't know if you can see it. Let me change the color. Maybe it's better if I change the color. Give me a nice color, red. Do you see how the red one is a solid line? There's a solid red line here, but there isn't here. Or maybe there is. I can't tell. Is it 0? It looks like 0. I'm positive it's 0, but how do we find that? We could be looking all day. We could be zooming in and never see it deviate from 0. That's no proof that it's 0. It just means it's a really tiny number. It could be 0.00001. How do I know it's 0? If I take this function, if I take the derivatives, so I would get, okay, what's the power rule say? Who's my power rule expert? Garv. What's the derivative here? 14 times 4/3
X divided 4/3.
Subtract 1 from it, so it's 1/3. So then this is going to be same thing, 8 times what?
4/3x.
1/3 raised to the what? What's 1/3 minus 3/3? There's the answer right there. Okay. Minus 2/3. Okay, that's the first derivative. What's the second derivative going to be? Do it again. God, do it again. What's G double prime going to be? Bring the power down.
1/3.
1/3. And what is 1? That's minus 2/3 because we just did that one. And then this one's going to be, we have to bring the
2/3.
right? Minus 2 over 3.
And 2. 5 and 1 minus.
Nope, subtracting. So what's minus 2 minus 3 is minus 5. And you could do it here too. You could look here. You could do minus 2. This 2, and there it'll tell you. Okay, so there's the second derivative. Okay, here's the hard part about this. Take a look at this. This is really crazy. Can you factor anything out of this? Okay, forget about the numbers. Just look at the variables. This is x to the minus 2/3, and this is x to the minus 5/3. Which one is smaller? Which number is smaller, minus 5/3 or minus 2/3?
Minus 5 compared to 5.
Yeah, so I'm going to factor that out. So I'm going to put this in the front, and I'm going to get rid of this. So that's gone, right? Gone. When I factor, what do I multiply minus 5/3 times what? X to the what thirds is going to give you times x to the what? It's going to give you the minus 2/3 you had there. What can you add to minus 5 to get minus 2? Minus 5 plus what gives you minus 2? Thank you. That's 3/3. 1. So this right here just becomes x. So this guy right here, so this one right here is giving you a fraction. That's giving you that number over there. This guy, that's giving you that number. But this number here, x to the minus 5/3, that's giving you the other line. That's undefined at 0. Okay, if I put 0, g double prime of 0, it's undefined. Anyway, that's how I know it's 0, because it's undefined here. All right. Enough of that. All right. Anything else from here? Where do I find the graph is concave down? What do I do to find that? This one's actually pretty easy. You could take the regular derivative twice and set it equal to 0, less than 0. Okay. All right. Critical numbers, second derivatives. So I'm not likely to ask this question. But if it says find the critical numbers, so you have to take the derivative and set them equal to 0 and solve. So you get 0 and minus 21/4. And then you have to plug them in to the second derivative. And that's what the second derivative test is. All right, and that's that. Okay. All right. I think I'm done with this. Okay, that was the local linear problem. No, that was somebody else's problem. All right. I'm not likely to ask you this sine of 1/2 thing because the local linear, it's yeah, it has problems. Okay, closing that out. I think that's it for today. Do you guys have any questions about anything? You need to practice your antiderivatives. Other than that, I think
It's hard.
What?
The intervals there is hard. I don't understand it.
The integrals or the antiderivatives?
I think, well, either both of them, but I'll rewatch the YouTube video to see if I can
And
get.
you know what? I will tell you is that you know how you can check things on Desmos if you want. Like you can't. Okay, so here's what you can do if you want to know if your answer is right. And you want to use Desmos to check. All right, so let's try this one right here. Let's check this guy right here. Okay, it actually starts as this. Okay, and then the answer was this. Okay, the way you can check it on Desmos is you can't do antiderivatives, but you can do derivatives. So get rid of the antiderivative here. And it'll graph that function. You see that purple line? Now, take the derivative of your answer. Okay, the only thing is I got to get rid of that plus c because it doesn't know what plus c is. Okay, take the derivative of your answer, and do you see how they're graphed the same? That's how we know that this answer is the same as that. Okay, so that's a way to check it on Desmos. But you could do it on a much smaller scale. You could just do this. See, these are the same. So if you're not sure what the antiderivative of 9x to the 9th is, see this. And you see they're the same function. Okay. I want you to practice these some, and we'll talk about it a bit more next week. Okay. We have a lot of antiderivatives to do, though. So for this test, it's only going to be 1 or 2 questions, maybe 3, maybe 2. Not much. But for 20 questions, this is mod 7. We've met 14 times, and we've only done antiderivatives once. So asking more than 2 questions would be poorly weighted. So 1 or 2 questions. Okay, any other questions before I let you go? Okay, well, I'm done. Y'all can leave.
Have a nice weekend.
Thank you, you too.
Professor, wanted to talk about
Like,
quiz 6. I messed up and I was gonna do it right after class and then I completely forgot. Is it possible I could still do it?
oh, did you send me an email asking me such?
Yeah, I texted you.
Yeah.
Is email better? Is it better to do email?
No, email for something like that is fine. Because if once the deadline's passed, it's not urgent. Let me see if there's any other questions before I answer your question. And hold on, I need to shut down the